Hello. So now this is section 4.5, which is about now absolute maximum and minimum. And also in this section, we'll be learning a few more thing. Uh, uh, well, it'll be related with this, but still we'll be learning a few more things as well. But before I start this section um, about the quiz. So again, I want to remind you about that. In case if I do not assign anything for any section, then you don't have to submit anything, right? So if I don't assign anything, then what do you submit, right? So even though I have made the tab and the Blackboard for all of these sections, so if you have already watched 4.4, then probably you already noticed that I didn't assign anything for 4.4, right? So if you don't see anything on that particular section, then you don't have to submit any quiz, right? So if I don't assign anything, then you don't have anything to submit. So yeah, even though you see the tab and the Blackboard, all right? And the whole point of this quiz is just to make you guys watch the lecture, all right? And the quiz problem I assign are very short quiz, just to make you guys watch the videos. All right, and whole point I make this video is to make you guys watch it. And if you don't watch the videos, then there is no point on making these videos as well, right? So anyway, let's start this section 4.5. Okay, so first let's start with the definition of absolute maximum and absolute minimum. So if I say, okay, so if I say f of c is greater than equals to f of x, and this c is any number, this c is a number, any number, then in this case, we say that this f of c, this whole thing f of c, is absolute maximum. Let's just say absolute max. And similarly here, if it's less than equals to, then this whole thing is absolute minimum or absolute min. All right, and also there is, well, this is one theorem, which we don't have to prove it, of course, but let's say, okay, let's say if a function f that is continuous, so there is a continuous function on a certain interval, all right? So there is a function, random function, something like this, and this function is continuous on this interval, let's say a and b. So in that interval, you can always find both absolute maximum and absolute minimum. All right, so that's the theorem. Now, anyway, let's move on. Okay, now, well, there are few processes. If a function is given, and we need to find absolute extrema, means both absolute minimum and absolute minimum. Sorry, absolute minimum and absolute maximum on a certain closed interval. All right, let's say closed interval is a comma b. Okay, now now the process of finding absolute maximum and absolute minimum is, first we need to confirm that the given function is continuous. All right, so it has to be a continuous function. And the second one, we have to find the critical number. And then once we get the critical number, then we have to evaluate f at in point, and also evaluate f at the given critical numbers. And from there, we can say that if we see the largest value, then we say the largest value is absolute maximum and the smallest value is absolute minimum. Anyway, let's do the example so we will see what exactly I'm talking about here. All right, so, okay, so now here, this is the example. So this function is given and we need to find absolute maximum and absolute minimum on a certain interval. All right, so basically when you're finding absolute maximum or minimum, the intervals will be given. Okay. Okay, now let's use different colors. So now to find absolute maximum minimum, okay, following this process, first we need to find the critical number, right? So let's find the critical number. So to find the critical number, we need to find the first derivative of f, so which will be 3x squared plus 6x to the power 2 minus 1 is still 1, plus absolute value of the derivative of 9x is still 9. So yeah, from here now, once we get this, now to find the critical number, we are going to assume f of x is equals to 0, right? And from here, we will say that this is 3x squared plus 6x plus 9 is equals to 0. Now solve for x. So let's just factor out 3. So the remaining terms are 2x, 3x squared plus 2x plus 3. And you can divide 3 on both sides, so 3 will be gone. So we just have this thing. So from here, I can say that x minus 1 and x plus 3, because we have a 3 here. So 3, using this 3, I can, 2x, I can say negative 1, and positive 3. Well, 3 minus 1 will be positive 2, right? So yeah. So from here, I will get x is equals to 1 and x is equals to negative 3, right? So since this is a polynomial equation, so all the numbers here are going to work. So this 1 and 3 will also work here. So that's why I can say these two are critical number. So if there is a polynomial, then we can easily say that whatever we get, the value we get from here will be the critical number. But if we have a fraction, then it's different, right? So I have showed that on FOPIN 4. But anyway, okay, so once we get this, now if you see here, now evaluate f at endpoint A and B. So endpoint A and B, so whatever the interval is given. So find the value of f at those points and also at critical numbers. So this means we need to find, well, first let's find the value of f at endpoint. So let's say first one, let's use f of negative 5. Okay, so now let's find, when I say x is negative 5, then what do I get? Sorry, it's, let's say instead of saying negative 5, let's say negative 4. Yeah, let's say negative 4. So if it is negative 4, then negative 4 to the power 3 plus 3 times negative 4 square plus 9 times negative 4 and 6. So using a calculator, you will get, I think you will get 26. Right, yeah. I think so, yeah, 26. Let me check it. Sorry, it will be 13. I use this in calculator and you'll get 13. Similarly, now if I say, now let's say f of 2, then you can use the same process. Then you should get, I think you should get -8. Okay, now I got the value of f at in point. So this number, the interval, we call this number end point. End point. Okay, so endpoints, because we have 2 points. So okay, endpoints. All right. Anyway, after that, now let's find the value of f at this critical number. So f of 1, you will get probably -11 here, and f of -3, you will get 21. Yeah, so once you get the value of all of this, so so the last one is the largest value will be the absolute maximum, and the smallest value will be absolute minimum. Okay, so the largest value we have here is this one. So this, so f of -3. Well, we'll get a negative, so this is absolute maximum, or let me just say absolute max. And the smallest number we have here is, it looks like -11, right? -11 is absolute minimum. Okay, so yeah, this is the idea, to find absolute maximum and minimum, an interval. So the interval, so basically whenever you're finding the absolute maximum minimum, the interval will be given. And also obviously the function will be given, and also the interval will be given. Okay, now let's do the next one. So here in this one, we're going to find a local maximum and local minimum, right? Which we generally get this using first derivative, right? So using first derivative, we will find increasing, decreasing interval, and then we can say if it is increasing, then we can, well, yeah, let's say if we have plus, minus, then in this case it is increasing, it is decreasing. So we said this is a local maximum point, right? Using f, first derivative of f, or f prime. But in this case, now we have to, well, here we have to find local maximum or minimum using second derivative, which we haven't done this yet. Using second derivative, we haven't found local maximum and minimum yet. So that's what I'm going to show it right now. So the idea here is, okay, now let's say, okay, we need to find this. Okay, we need to find this. Now let's say C is given, which is, C is a critical number. All right, and then we can, now a function will be given, certain function will be given. And then we can find that, let's say, once we also get the critical number, then after checking f double derivative, or f double prime, and evaluate this double prime at C, at critical point, and if we get this one positive, then we can say that at that point, C, is, well, here we have a positive, right? If we get this positive, it should be local minimum, not maximum. When you use a second derivative, all right? If the second derivative is positive at critical number, then we said that f of c is local minimum. Okay, and if f double prime of c is less than 0, then we say f at that point, f of c is local maximum. All right, so don't be confused with this. If it is, if double prime is positive, then it is local minimum. And if double prime is negative, then at that point, f of c, it's local maximum. All right, so keep this in mind. So using this fact, now let's find the local maximum and local minimum of this function, x to the power 3 minus 9x squared plus 24x. Okay, now we need to find a local maximum and local minimum. Local maximum and local minimum. Local min and max using second derivative. Okay, now here we need to, okay, first we need to find double derivative, right? But okay, first we need to find a first derivative. So the first derivative here, we will get 3x squared minus 18, right? 9 times 2, 18, x to the power 2 minus 1 is 1, plus 24, right? And then now after this, I need to find the critical number, right? So now let's say this is equals to 0. So 3x squared minus 18x plus 24 is equals to 0. So now if I take out 3, then we will get x squared minus 6x plus 8. Right? And then now I can factor, well, I can just divide 3 on both sides. So we'll just have this. Now, well, there is a negative 6 and we have 8. So using the factor of 8, well, I can use 4 and 2, right? So using 4 and 2, I can say negative x minus 4 and x minus 2. So negative 4, negative 2 will make negative 6, right? Okay, this is equals to 0. So that means x is positive 4 and x is positive 2, right? So from here, now I can say that these two are critical number, right? So now using these two, I need to find f, well, first let's find f double prime. Okay, so f double prime, using this, I can find f double prime of x, which is 6x minus 18, right? So once you get the f double prime, I have to use this, so I have to use these two critical number and plug that into the double prime. So f of 4 is equals to, there is an f4 here, is f4 here, right? I'm using the critical number, so x 6 times 4 minus 18 will be 24 minus 18 is 6. All right, so this is a positive number. So if f double prime is a positive number at that critical point, then we can say that at this point it will be a local minimum. So let's find this value. Because if you get a positive, right? If we get a positive, like I said here, if we get a positive, then at that point, f of c point will get local minimum, right? So this is positive, so at this point we'll get local minimum. So let's find that point. So that point will be 4 to the power 3, right? Because I'm using the f function. So 4 to the power 3 minus 9 to the power, or 9 times 4 to the power 2 plus 24 times 4. So using this, you will get, this is 4 times 3 is 64, or 4 to the power 3 is 64. And 16 times 9 is, well, that's negative, so 144. And 24 times 4 is 96. Yeah, 96. So from here we will get some positive number, of course. Minus 144, we'll get 16. So it's a positive number. Yeah, 16. But yeah, at this point, we will get minimum, or local minimum. Right. Now, similarly, you can also find that if, well, let me do it in the next page. Also, you can find, or it will be easy if I saw it on the same page. So now this was this point, right? Now let's say f double prime of 2. Let's see if we get a positive or negative. So f double prime of 2 will be, well, here, if x is 2, then it will get a negative number, which will be 12 minus 18 is negative 6. Yeah, so this is negative. So that means at f of 2, we will get a maximum. So f of 2, 2 to the power 3 minus 9 times 2 to the power 2 plus 24 times 2. All right, so you will get some number. And at this point, we'll get local max, right? So yeah, just, okay, let's assign this as a quiz. All right, I was not thinking to assign a quiz, but this is an easy one, right? So let's just assign this as a quiz. So write this whole thing, put this in your calculator, write the answer, and just say that this is a local maximum. All right, so the whole point of this quiz is just to make you guys watch the videos. I just want to check whether you are actually watching the videos or not. That's it. Okay. All right, so yeah, like I said, use your calculator, just write this answer. So this is a quiz. So this is section 4.5, right? So assign or submit this work on 4.5. 4.5 quiz. All right. Okay, so here after this, I guess you can do this on your own. So this is given, and find local maximum, minimum, local maximum and minimum using the same process that I did here using second derivative. All right. So this is not a quiz problem. Yeah, this is not a quiz problem. You can just work on this problem as a practice, because more you practice, it will be more easy in the exam as well. All right. Anyway, like I said, this is not a quiz. The only quiz problem I assigned was the last problem I said, just the easy one. Anyway, that's it for, yeah, I think that's it for this section. Yeah, that's it for this section. All right, thank you.